Okay guys, happy Monday. So this week we're only going to be posting stuff on Monday and Wednesday and have maybe more time for reflection on Tuesday and Thursday. So we are moving into the second part of this chapter, and this part of the chapter deals with segments of circles. So you can see the learning target is I can solve problems involving segments. So that's what we're going to be working on the next couple of weeks. And you need to retain what you learned about angles, but add to it what we're learning about the segments. So the first thing we want to talk about are tangent and radius relationships. We had talked about this a little bit earlier. If you have a tangent, which touches, is a segment or a line that touches the circle at one point on the circle, and the radius that connects to that, this will form a 90-degree angle. And we talked about that actually previously in this chapter. And remember I said this is kind of like an angle created on the circle will be half of the intercepted arc. And because if I connect the radius and go all the way across, I've made a semicircle. And that 180 degrees, we would take half of it because the angle is created on the circle, and it would be 90. So what we need to know and what we're going to use is radii are perpendicular to tangents at the point of tangency. Okay, so whether this was a tangent connecting to a radius or a tangent connecting to a diameter, it would form a 90-degree angle, and that's what's going to be important. Because we're going to have a 90-degree angle, we're going to look at some triangles that were going to be created here, and you will see that we're going to use Pythagorean theorem or maybe right triangle trig to find what is missing. Okay,